Welcome to MRL. In this learning session, we'll be learning about areas related to circles. And before I proceed with the areas related to circles, let us first establish a relation to find out the circumference of a circle. Now, what is the circumference of a circle? Circumference of a circle is the perimeter of a circle or the boundary of a circle, and it is denoted by C. Now, to find out or establish a relation to find out the circumference of a circle, let us consider a circle, measure the circumference of the circle C and also the diameter of the circle D. Now, take the ratio of the circumference of the circle and diameter, that is C divided by D, is equal to a constant, and that constant value is 22/7 for any circle, and it is denoted by a symbol pi. Now, C by D is equal to pi, or C is equal to pi D. C is equal to pi D is a relation or a formula to find out the circumference of a circle if the diameter of the circle is given. Now, we know that D is equal to 2r, that is diameter of a circle is twice radius. Therefore, replacing D by 2r, we get C is equal to 2 pi r. This is again a relation to find the circumference if the radius of a circle is given to us. So, we have the relation C is equal to pi D to find the circumference of circle and diameter is given, and C is equal to 2 pi r when the radius of the circle is given. Now, area of a circle. Now, we know that the region of a circle and including its boundary is known as the area of a circle. So, the measure of the region of a circle including its boundary is known as area of circle. But here we are trying to establish the formula to find out the area of a circle. So, let us consider a circle of radius r, and as you know, the circle is a non-uniform figure, therefore we cannot find the area directly. Now, we adopt an indirect method. So, divide the circle into a number of sectors and arrange these sectors as shown to form a rectangle. So, this is sector 1, sector 2, sector 3, arrange them to get a rectangle. We find that the length of the rectangle is half of the circumference of a circle and its breadth is the radius of the circle. Now, if we find the area of the rectangle, then we have found out the area of the circle. So, therefore, the area of the rectangle is equal to length into breadth, that is half into circumference into radius, that is half into 2 pi r into r, because circumference is 2 pi r, and 2 will cancel, we get pi r square. Therefore, the relation to find out the area of a circle is pi r square. Remember that. Now, the next important study is the sector of a circle. Now, what is sector of a circle? Again, sector of a circle is the region of a circle enclosed by two radii and the corresponding arc. Now, if you look at this figure, OA and OB are two radii and AB is an arc. So, the region enclosed between these two radii and this arc AB is known as the sector of the circle. So, also the area enclosed between the arc BA and the two radii is also a sector. That means in a circle, when we draw two radii, we get two sectors. One is called as the minor sector, the other one is the major sector. Now, minor sector is the region enclosed by the two radii and the corresponding minor arc, and the major sector is the region of a circle bounded by two radii and the corresponding major arc. Here, AB is the minor arc and therefore this is the minor sector. Here, BA is the major arc and therefore it is a major sector. So, remember theta here, theta is the angle of the minor sector. Therefore, theta is the angle of the minor sector here. If theta is the angle of minor sector, then the theta of or the angle of the major sector is 360 minus theta. Remember that. Now, to find the area of minor sector, that means how to find the area of the minor sector. To find the area of the minor sector, that is ABOA, the procedure is very simple. We see that the angle theta, which is the angle of the minor sector, if you increase the theta, the area of the minor sector also increases. That means theta is proportional to the area of sector. Theta is proportional to area of sector. Therefore, I can take two ratios here, area of minor sector divided by area of circle. Area of minor sector divided by area of circle is equal to degree measure of the minor sector and degree measure of the circle. We know that the minor sector subtends an angle of theta at the center, that is the central angle is theta, whereas for a circle the angle at the center is 360 degrees. Therefore, area of minor sector is equal to theta theta, that is degree measure of minor sector, divided by degree measure of circle is 360 degrees into area of circle. Taking on the right side we get area of circle. Therefore area of minor sector is equal to theta by 360 into pi r square. So please remember, to find out the area of the minor sector, the formula or the relation is theta by 360 into pi r square, where theta is the central angle of the minor sector and 360 degrees is the angle made by the at the center by the circle, and into pi r square is the formula to find out the area of circle. Therefore the formula to find the area of minor sector is theta by 360 into pi r square. Now let us understand how to find out the area of major sector. And if you look at the figure, this is minor sector and this is the major sector. Now if I subtract this portion of the circle from the area of the circle, that means area of the circle minus the area of the minor sector, we will get the area of the major sector. Therefore area of major sector is area of circle minus area of minor sector, that is area of circle is pi r square and area of minor sector, as we know, is theta by 360 into pi r square. So using this formula we can find out the area of major sector. Now the procedure is very simple. Find the area of circle first, find the area of minor sector, subtract the area of minor sector from the area of circle, we will get the area of major sector.